Hello, everyone. Thanks for joining this webinar. My name is Kostas Rongeris. I'm the head of marketing of Spectro Cloud, and I have the pleasure of having our CTO and co-founder, Saad Malik, with me today.
Everyone, nice to be here.
So, Saad, today is the first time we're showcasing version 2 of Palette online. I know there's a ton of features that we've added in this new version, but I wanted to start from scratch. Let's really get into the life of a Kubernetes operator, of an IT operations person, of a DevOps engineer. So Palette exists to make Kubernetes more accessible and manageable. And we often talk about how unique our product is when it comes to full stack management, data operations, and how we allow our customers to use any location and any integration that's relevant to them and their project. Why is that important for organizations?
Yeah, a great question. And this is frankly something that Kostas, me and you talk about all the time, that Kubernetes is not just one thing. Kubernetes is so much more than just the core layers like the networking and storage stack. It has to do with all the various integrations that go into Kubernetes. Everything from your logging, your monitoring, your security, your service mesh. In fact, what we find is that on average, customers run 15 to 18 different types of integrations per Kubernetes cluster. Today, if you take a look at the CNCF landscape, there are over 1,700 different technologies that go into one of these different layers that different customers are using. Now, just the sheer volume of these integrations goes to show that these integrations exist because people have different requirements. Different teams are looking for different capabilities. Whether it's, somebody's more concerned about latency in their API server versus somebody's more concerned about potentially having observability data in their API server. Different teams and different applications have different requirements. And so what we find is that even though development teams and operations teams want to be able to provide all of this flexibility for people to choose, IT operations and DevOps have a hard time of figuring out how do you give the developer the flexibility of being able to choose their integrations, but still provide manageability and usability for them to be able to manage across multiple teams, across multiple different organizations, these requirements.
Yeah, it's the typical conundrum that we talk about, like this swing of, I start with experimenting with Kubernetes, starting deploying and testing. And when things get serious and when you need to move to production, especially when it comes to larger organizations, IT normally takes over ownership of Kubernetes. And then the real challenge begins because you have to balance the flexibility that developers are asking, because they don't care about infrastructure, they care about the additional application services that's required for the projects versus how can I, conduct the whole lifecycle management tasks as the requirements change. And more importantly, as they change over time, times the different projects, the multiple different projects that larger organizations have. Cool. Okay. So before we jump into the product, because this is a live showcase, and I'm going to ask you to kind of wear your DevOps engineering hat and start using the product as you would do if you were deploying Kubernetes and managing them. But before we do that, we talk a lot about lifecycle management, right? Day 0, day 1, day 2. What does that mean? What's day 0? You're an IT operations person, and there's a development team that's reaching out and saying, "Hey, I have this application project."
Great question. I think the way to even answer this question is maybe through an example. One of the more typical examples we see for our development teams asking for are AI ML based clusters, right? Clusters that potentially have Kubeflow or PyTorch or TensorFlow built into these clusters with all the different capabilities that they need to be able to run their data science and ML workloads on top of. When this request comes into a DevOps or an SRE team to be able to manage a cluster, the day 0 really is about figuring out what are the various requirements that the development team needs, right? This could be everything from the AI ML specific technologies. I want to add my TensorFlow, I want to add PyTorch, I want to add my GPU drivers, but it also goes a layer below that. Right, they obviously need access to some logging and monitoring, the traceability, my service mesh integrations. So for my responsibility as a DevOps engineer is trying to identify what best technologies are going to be suited for this development team based on their requirements and based on what my organization allows in the ecosystem for different layers. So first aspect is designing what the actual cluster will look like. And the way we do that in Spectro Cloud Palette of course, is building a blueprint that we call a cluster profile that becomes a repeatable template that I can not only use to manage the lifecycle for a single cluster, but as many clusters as I want to.
Right.
Day one, yeah.
You're defining the prototype, right? You're defining that blueprint. That's day zero. Okay, let's go ahead and see this in action.
Let's do it. Let's do it. Give me 1 second while I share my screen. And can you see the screen, Costas?
Of course, we can see it.
All right. I'm going to move you right to the middle. So, okay. So I'm logging into our demo environment. We're big Star Trek fans over here. So every system that we have is based on Star Trek ships and captains. As we log into the platform, we obviously authenticate with both single sign-on with SAML or OpenID Connect. And the authentication not only provides us with the user information, but we can also get information about authorization. So based on your logging in through your Okta or Azure AD or any other connector, we're able to figure out which projects and which groups you have access to. Projects is a mechanism or a grouping of how we provide multi-tenancy within the product. So you can have different projects for different use cases for different teams. And the groupings might be capturing things like the cluster profiles. These are the blueprint or template, the Kubernetes clusters, audit logs, cloud account, and other settings. Now, depending on what projects that I have access to, I can, of course, switch to those projects and get access to those resources.
As organizations scale, as development projects scale, IT is tasked and in some cases overwhelmed with having to manage and switch between different projects. So the whole idea behind Palette and the whole user experience was designed exactly to cater for that easy switch between the different projects, maintaining the different configurations for each one of those projects, right?
Absolutely, absolutely. So within the default project, what we're going to do next is go to the cluster profile section. And I'll show you a simple cluster profile like a prod VMware one, just to show you the blueprint and the template aspect of this. So the cluster profile captures the core layers like the operating system, the Kubernetes version, the networking storage, and anything that sits on top of it, like the load balancer that we see over here, the service mesh, the ingress, and system apps, logging, monitoring, are what we call the add-on layers. What we're going to do next is actually build a AI ML specific cluster profile, just to kind of show you what that experience looks like.
I think one of the biggest, like just this easy visualization of the different layers beyond just the core 4 layers, operating system, Kubernetes, networking interface, and storage interface is super important for IT operations, right?
Absolutely. Yep. Let's go ahead and build a new cluster profile. And then we can specify a name. This is AI ML Demo 2. We can specify the type of the profile. Full essentially means I want to model both the core layers as well as all the add-on layers. Frequently, what we also see our customers, especially in multi-cloud use cases, is where they'll have certain configuration, whether it's ML-specific technologies or security technologies, that they want to have the configuration applied not just to their public cloud clusters, but to the private cloud, their edge clusters. And so what they do is they can model all those specific configurations into an add-on profile and reliably and consistently apply that configuration to any cluster technology. In this case, though, we'll pick the full cluster profile since we want to capture all the layers in a single cluster profile. We can add a tag like the dev tag over here and then select next. Now we're specifying which cloud environment or which cloud location are we picking for this cluster profile. For the public cloud side, we support both VM-based Kubernetes. So for example, on Amazon, we would provision the EC2 instances. But on public clouds, you do have the managed Kubernetes options as well, whether it's AKS, EKS, and GKE. For this demo, let's go ahead and pick the actual EKS cluster type and then select next. And now we're going to begin modeling the various layers for the core layers in the Kubernetes stack. From the public repository, we can pick the Amazon EKS optimized Linux, right? One thing that's important to note is that we really care about flexibility for customers to even bring in their own images, whether it's at the OS level or any of the layers that sit on top. The way we provide that is through a concept called a registry, where customers can create their own private repository or private registry and upload their own content. And again, it could be an operating system image or any of the layers that sit on top in the Kubernetes stack.
So here you're not deploying anything in reality, but you're defining a configuration, a cluster configuration that can be used as a blueprint. And the beauty is that when you select the target on the next page, on this page here, you have pre-validated, pre-tested integrations that work for the specific target that you selected, right?
Absolutely, absolutely. And as we kind of go through the demo itself, you'll see even more that because we pick Amazon, you're seeing Amazon-specific technologies integration. This is the Amazon EKS Optimized Linux. Even the Kubernetes options, because it's EKS, the versions of Kubernetes that are available are directly pulled from the EKS console, right? What versions are supported by EKS. The day they add 1.22 support, our platform will automatically also start supporting that. Depending on which cloud technology you're picking, obviously you'll see different versions of Kubernetes and different integrations available for selection. For this demo, yeah, please.
We'll talk about how easy it is to upgrade and change move between different versions in the cluster profile, and how is that reflected later in the production clusters.
For the EKS, the cluster here, the Kubernetes EKS 1.21, notice that we do also provide flexibility for customers to override EKS specific parameters, whether it has to do with logging configurations or setting up your OpenID Connect or passing additional role policies. The defaults, of course, will work for majority of use cases, but we do provide the flexibility for customers to override any specific setting that they need to. In the next layer for the networking, we can pick the Amazon VPC CNI right at the latest version. And again, for the storage, we can pick the Amazon EPS storage, but we do provide integrations with Gluster as another distributed file storage, NFS, or even Rook and Ceph if needed. We'll pick Amazon EBS at the latest version and then select Done. So now we're done modeling the core layers. We can add all the various integrations that sit on top. Now, typically, a cluster will always need a load balancer. Luckily, with Amazon, the load balancers are already added because EKS provides it out of the box. But you still need an API gateway. You need an ingress. So in the ingress category, right, we provide a number of out-of-the-box options in a public repository, like Ambassador, Kong, Nginx, and Glue, to make it really easy for our customers to pick and choose the technologies that they want to use. If I pick in an Ambassador at the latest version, I have the ability to also customize any of the Ambassador configuration I need to. Maybe specify, I want higher availability. Instead of 3 replicas, I want 5 replicas. I can make the modification directly here.
I love the fact that we can inspect the code really for each one of the different layers that easily. I wanted to ask you something else. What's the attached manifest that I see under there? Great
question. So, and actually Ingress is a really good example to talk when this would be useful. So typically Ingress is where you do your TLS termination, right? This is where you have the public and private certificates, your SSL certs that are used. Now, you can either use a technology like Let's Encrypt that will generate your public key and private key for you, but in certain organizations, that public cert and private key are actually provided by your IT operations team. They'll generate the certificate, public key, and private key outside, and they have to feed it into the system. Now, what are ways of doing that? Well, one way of doing that, of course, is provisioning the actual cluster and then manually going into the Kubernetes cluster, creating a secret with your public key and secret key. Or because you're still declaratively defining the entire stack from your Kubernetes down to all the integrations, including your Nginx, why can't you also attach that secret for your public key and private key directly in the profile? So what attached manifest is exactly for that use case, where I could say, hey, I actually have my public key and private key generated outside. I'm going to make a new manifest for certs. And then essentially, once you do that, you can go ahead and paste in, the actual resource of the Kubernetes manifest for creating a new secret, right? And whatever the actual value for that is. So now you have a single place to manage everything that relates to your Nginx configuration.
Great stuff.
Cool. Let's delete the actual added manifest. I can click Done. We can add a few more integrations that are typical in a AI ML like cluster, right? Obviously under logging, we can see different solutions like EFK, FluentBit, Splunk, and Datadog. If I go into monitoring, we provide a number of different integrations. The most common one that people use, especially in the open source, is Prometheus and Grafana. So we can select that. One thing to also notice is because these technologies are hosted by us, like you mentioned, Costas, we pre-validate them, that these integrations work with every single Kubernetes version that we offer. And more than that, we also have very specific placement configuration and placement constraints that make recommendations that if you're adding something like a Prometheus Grafana, make sure you automatically have an ingress controller. And on top of that, because we actually know the technology inside and out, we can even provide a schema for the various integration. So in this here notice that Prometheus Grafana has an error on line 5888. Essentially, it says that admin password needs to be specified. And because it's a password field, we know to automatically mask it and have at least a 3-character long regex to it. Making it users easy for them to build, configure, and operate their clusters with any technologies that we offer.
And the other aspect of this is when you're pushing something into production, you really want to know that the combination of those layers, not just the individual layer, will play well together, right?
Absolutely. And because we have all of these metadata that knows of which technology works with other ones, we will make recommendations saying, hey, this version of Ambassador has not been tested with a newer version of Kubernetes, right? Maybe you should do additional testing on that. These are the kind of things that make it easy for customers to be able to pick technologies and know that another organization like Spectro Cloud has pre-validated these things so they work better together.
I see another button that says import, and I really, really want to ask what this one does.
Let's talk about that. So one of the actual interesting use cases is where customers have existing clusters with existing applications or configurations. The applications could be just manifest or directly Helm charts. What we allow customers to do is essentially import a cluster into Palette, and from there be able to read what are all of the applications that are currently running in that cluster and be able to model those applications as individual layers. Now, this way, even if you don't have the original CI pipeline for pushing a specific Helm chart or application into additional clusters, you can easily import that entire app, that entire configuration, and model it into a cluster profile, and then repeatedly deploy that application or configuration into any cluster that you have.
So if we have a big customer, for example, or a big expanded environment that's heavy on one side, let's say the data center side on OpenShift, but they have other deployments somewhere else, you can use easily Palette as the Uber control plane of all the Kubernetes clusters, right? That's the thinking behind there. Cool.
Absolutely, yeah. And as we kind of go more into the multi-cluster fleet demo, right, we show all the different cluster technologies, Palette really becomes a single pane of glass where you get full visibility into the health and operations of all your clusters, even clusters that are not provisioned through Spectro Cloud, imported clusters like OpenShift.
Of course.
We're going to add just a few more different layers, but as you guys can notice that we have around 35 different integrations in many different layers. These are most common integrations that our customers use. Maybe under the service mesh category, we can add a popular service mesh like Istio, at the latest version. And then again,
Kubeflow.
And we'll add Kubeflow as well. So like if you go under the system application layer type, here we have some of the more other types of applications people bring in, and we can add the Kubeflow layer. One more thing about our Kubeflow integration is through the power of the customization and flexibility, we allow users to even customize Kubeflow. Do you want to install your TensorFlow package? Do you want to install your PyTorch or your Jupyter books? All these things, are very defaulted, but you have the ability to configure them the way you want to. If I select done, make sure everything looks good, and then select next. We can verify that the cluster profile looks good, and then once we click on finish, this goes ahead and actually creates the cluster profile.
Okay. So you've built the recipe, you've built the template, you haven't really deployed anything, right?
That's correct. For that, let's jump into the clusters view. So the first thing I'll do with the clusters view is I'll switch to maybe a view of all the different environments, or I'll sort by the environments. And you can notice that we have clusters that are deployed and monitored from VMware, from Azure, from Metal as a service using MAS. We can even import clusters like OpenShift and get the same level of health and visibility as you do with other cluster technologies. Again, from this view, you can do two operations. You can either import any additional clusters if you need to, or you can say, let's provision a brand new cluster. So let's go through the workflow of provisioning now this AI/ML cluster profile that we just built onto an EKS environment. We'll select create, specify a name, AI/ML demo 2. We can specify any tags here. One more thing to note, any tags that you specify either in the cluster profile or in the cluster are also pushed to the cloud environment. So for example, this dev tag that I added, any resources that we provision from the VPCs, the subnet, the security groups, even the EKS cluster and its node groups will automatically have these tags added so that if you have your own tooling like Cloudability or Cloud Health, you can very easily get visibility into which resources are created from which user, from which tenant, from which project.
Great stuff.
So if I select next, here we pick the actual cloud technology that we're provisioning into. We can pick the managed EKS, and then we'll select the AI/ML demo 2. And what do you think these should, yeah?
Sorry to interrupt you. One of my favorite features is that thumbnail type of image of the layers, so you can understand, which one is which stack that you've cluster profile rather that you've built.
Yeah, it looks cool, huh? I agree. For the here we have the ability to make any override. So the cluster profile, of course, was the default configurations that we're going to be using as a recipe to build out clusters. But you might still need some level of configuration. I want to optimize. Maybe for this instance of Kubeflow, I don't want to use TensorFlow. I don't want to use PyTorch. You have the ability to make any specific customizations, at this layer.
Before you deploy based on the existing template. Got it.
Yep. If I select next, now we're picking the actual cloud account. So in the admin level screens, you had a place where you can register Amazon cloud accounts. We support both for access key and secret key, but the more common way of integrating with Spectro Cloud now is using an assume role, where you only specify the role and the ARN that we're going to be assuming, so you don't have to give full access into your account. We can pick the Amazon EKS cloud account. Now for provisioning, we support two modes. We can either do what's called dynamic provisioning, where we will, per cluster, dynamically provision all the infrastructure required. This would include things like provisioning the VPCs, the subnet, the NAT gateways, the security groups. But we do have many customers who have additional resources that are also created into alongside with their cluster. This could be things like an RDS instance. This could be other applications that are run beside the Kubernetes cluster. And so these customers will pre-provision the actual infrastructure, like the VPC and subnet, and ask us to statically place the cluster into their VPC, into their subnets. So both modes are supported, not only through our UI, but through our automation as well, whether it's API driven or through our Terraform provider. For the region, we can select, US West 2. And then for the SSH key name, we dynamically pull the SSH keys available in the system. We can pick default, and of course, a few other configuration options. In the next tab, because we're provisioning now a EKS cluster, we're not managing the master pool, but what you can specify, of course, are configuration for your worker pools. If you're building a relatively large cluster, you might have multiple different worker pools. Some might have GPU instances, some might be compute optimized or memory optimized, right, and as needed. We can specify our auto-scaling configuration, the minimum number of nodes, the maximum number of nodes. And then for the actual node types, we support both on-demand instances as well as spot-based instances. For the instance type, you have, obviously we pull all the instance types available. You can even filter directly here. I want to go to T3 extra large. We feel a little bit more rich today, right? So we also pull in the actual price of the instances, like 16 cents an hour, along with their CPU and memory hardware configurations.
So you're pulling all this information from the AWS dashboard, basically, right? Because Palette integrates with all the different clouds, both at an IS layer, but in this case, at the managed Kubernetes layer. So that's dynamically updated, I'm assuming, right?
Absolutely. It's updated on a daily basis, where we'll make API calls to Amazon, to Google to Azure, all the public clouds we support, to be able to dynamically pull the latest instance rate cards. And based on that, the number of instances you specify, the control plane cost, we can even give an estimate of what the actual infra level costs are going to be for this cluster. One more minor comment is we do also support Fargate profiles for Amazon. A good use case for Fargate profiles is if you have a lot of spotty workloads which only run for a couple hours a day. Instead of potentially provisioning and having really idle worker nodes, you can configure Fargate to say, go ahead and launch a brand new node for a specific pod. And as soon as that pod or spotty workload is over, go ahead and deprovision the Fargate nodes.
Yeah, the whole idea around cattle and immutable infrastructure, right?
Absolutely. Okay, so in addition to provisioning the cluster and of course managing the different integrations that go into the cluster, we do a number of other day two operations. And we'll go a little bit deeper, Costas and I will go a little bit deeper into what some of those day two capabilities are, but aspects like I want to configure a policy to update the operating system on a nightly basis or on a weekly basis here. We can run things like your conformance scans, your penetration scans, even security scans using CIS. And these could be all scheduled using policy. And of course, business continuity is really important. How do you ensure that you have redundant backups of all your different namespaces, of all your different persistent disks? So you can integrate with technologies like Bolero to back up the entire cluster and store it into an S3 compatible storage.
So we've incorporated basically at the day one kind of pre-deployment phase, we've incorporated best of breed tooling from the open source community from the day two realm effectively. And I do have a long list of questions when we get to the discussion to the day two operations. But this is brilliant.
Awesome. Okay, you click on validate to make sure everything looks good, and then you can click on deploy. And then at this point, Palette will take the specifications for the cluster profile and the cluster spec we specified and begin provisioning the actual cluster. It can take anywhere from 12 to 15 minutes, depending on how many nodes you've added, how many different integrations you've added. So what we're gonna do next, instead of us waiting 12 to 15 minutes for the cluster to be provisioned, let's jump into an existing cluster to see what that looks like.
Sure, let's go ahead and do that.
So let's go into the clusters page and we can select the EKS Dynamic 2. So this is a cluster we provisioned a few days ago. Notice that the cluster is in a healthy state. It's running Kubernetes 1.18. All the application and add-on profiles that are added into this cluster is very similar to the one we just deployed. And you can also access those application services directly from our UI. More than this, the health information, we also get monitoring information directly from the cluster, both at the cluster infra level in terms of what is the resource utilization of my CPU, of my memory, even down to the namespace level.
Let's talk about namespaces, because I hear lots of conversations happening in Spectro with customers about the need to have this super granular visibility when it comes to namespaces.
Yeah, absolutely. And I think one of the key ways to look at that is inside the Kubernetes cluster, what are the workloads that are actually running? So if you switch to the workloads tab, you can see all the various namespaces along with the actual CPU and memory utilization of what's running in those namespaces. I can even drill down to a specific pod view where now I'm looking at all the different resources that are running across all the namespaces. And of course, you can slice and dice this information by number of hours, by number of days, as you want to. You can filter even these views by specific namespaces. So now only show me pods or deployments or daemon sets, et cetera, that are running in specific namespaces. Where this becomes really useful, and Costas, to your point, is tying it down to the overall usage cost. Mm-hmm. So the way to think about this is the actual cluster itself is, as of right now, it's been running for a few days, has cost me around $1,200. But if I have a large multi-tenant cluster that has multiple teams running applications on it, how much of this cost should I attribute to team one versus team two? And typically what we find is that teams have access to just one or two different namespaces. So what if we can say that this team one, this orange or this color over here, is using 5% of the actual resources in the cluster, but another color, maybe the yellow one, is using 50% of the resources. With that information, we can attribute that 50% of the cluster cost needs to be team 2 versus team 1. This is the level of visibility that we were able to get. Yeah.
You're giving away clusters, but you're not giving away control of the clusters.
Yep, absolutely. And speaking of that, so more than just the cost aspect, of course, we do things like the day 2 management of your actual profiles. So potentially, you may have some add-ons that you're already running inside the cluster, but you want to be able to add or modify additional configuration into those clusters. That's essentially what the profile tab is for, where I can either modify configuration, or if you have an additional add-on profile that has your security modules, your security configurations, AI ML configurations, those are additional add-on configurations you can add into the cluster directly from here.
Amazing, brilliant. Okay, so we've deployed the cluster. The application we've deployed is successful. 2 months, 3 months down the line, I need to scale because I have more users. Let's take a look at how easy it is to scale a cluster.
Absolutely. That would be under the nodes tab, is where we see the visibility of the node pools running in this EKS cluster, along with the actual nodes that are powering the cluster here. So what you can do from here is you can say, I can either scale up directly the worker pool. The one way of scaling, of course, is just saying, hey, add an additional node into this existing node pool. The other way of scaling, people usually also forget, is you can also scale upwards. By that, I mean, instead of using T3 extra large, you can say, I'll use T3.2x large, right? Double the capacity of the nodes. Any modification you do to the instance type configuration or to the disk size here will be a rolling upgrade, where we'll add a brand new node with a new configuration, and as it joins into the cluster, begin deprovisioning the older nodes itself, as workloads are migrated over.
And I like the consistency of the cost estimation that's still here when I'm doing scaling, right? It was before, but I can see it here when I need to make a change.
That's exactly right, because to be honest, day 1 provisioning is something people can do, but most times these clusters are still long running. They have to be maintained. That's where day 2 operations becomes really important. So we should have the same level of visibility as you do when you do provisioning, as you do when you're doing upgrading. So let's do a scale operation. Like you said, you have been 2 months running. Let's go ahead and add an additional node. Instead of scaling this way, we can also add an additional node pool. And maybe this one, we can make it a GPU-based node. So we can select add new node pool, and then we can specify GPU pool and specify the minimum and maximum size. Again, the same type of configuration, the on-demand versus spot instances. For the instance type, we can start typing in GPU instance, and we'll pick a cheap GPU instance in 8 CPUs and 16 gigs of RAM, and you can specify the disk size. When I click on confirm, right, within a few seconds, right, a brand new node with a GPU configuration is being added into the pool.
Amazing. I hope you're not using the marketing budget for this.
Do you guys have a lot?
Okay, so we started touching on the day 2 operations side of things. What happens if there's a new version of Kubernetes and I need to upgrade, right? What does that mean when what we're doing here is based on declarative management? What happens?
Yeah, great point. So because we're no longer managing individual snowflakes, right? You're not going to go into your 5 clusters or 10 clusters or potentially hundreds of clusters and make the same modification one by one. The declarative management approach really for us is a cluster profile. Everything is defined as a desired state in your cluster profile, and then those changes are what's reflected in your cluster. So to your question, right here, I have my actual EKS Dynamic 2 cluster, right, based on a prod EKS cluster profile, running Kubernetes 118, right? If I want to do an upgrade for Kubernetes, we'll jump back into the cluster profile section. We'll look for that cluster profile, prod EKS, and then on the Kubernetes layer, we can upgrade it from Kubernetes maybe 118 to maybe Kubernetes 1.19. We can also add a comment, something like, changing to 119, and you'll see where this becomes useful. If I select done and click on save changes, any changes you do to the cluster profiles, to the clusters, are of course audited in the audit logs. You can also add additional notes with an audit message, something along the lines that, hey, kubectl node debug is awesome in 119. Again, then you have full visibility into who's making what change, why they made a change, and everything is tracked inside of your audit logs directly.
And what you've upgraded is not the actual cluster, of course, but it's that blueprint, it's the cluster profile. So I'm really curious to see what that means within the Palette environment. How are you going to be notified that, hey, the cluster profile has changed, what's next?
Absolutely. If I go into the clusters view here, notice that my cluster EKS Dynamic 2 had an update available. If I had other EKS clusters built off of that same profile, all of them would show an update available notification. Now, it's up to the IT operations team to say, hey, I want to roll out those changes to one cluster at a time, make sure everything is good. Or you can also attach additional policies that will automate these rollouts. For the time being, let's do the manual upgrade just to show what the experience looks like. If I go into the actual cluster, notice now there's an update available button. I can select it, and you'll see exactly what's changing, or whether we're changing configurations of any of the config here to anything else. You'll see before you apply what changes are going to be applied into the cluster. So in this case, we're modifying Kubernetes 118, going down to 119.
Again, you're inspecting the actual code side by side, just so that you can see the updates, and then you make the decision just like that. Okay.
Yep. And this whole thing could be driven through the UI or driven the exact same way through Terraform or using APIs.
Okay, Saad. So we touched a bit on the backup restore element. Let's double click into this one, but also into what are the other best of breed components, open source components that Palette leverages.
Sure, absolutely. So if I go into the More tab and click on backups, here you can see all the backups that have happened for this specific cluster. If I had configured a policy that said, schedule backups on a weekly basis, then these backups would happen automatically. And most of our customers do perform backups on a nightly basis that covers everything. What you can do, of course, is doing an ad hoc backup. Click on Create Backup. This goes ahead and shows all the different namespaces available in your cluster. So you can say, I want to back up everything, or I want to specifically back up a namespace. And you could even have the option whether you want to back up the disks themselves. What's really cool is depending on which cloud technology you're using. So in the case of Amazon, we will do snapshots of your actual disks. But if you're using something like an on-prem, like if you're using your VMware or OpenStack or even bare metal, we will use a technology called Restic to back up the entire archive of your disks and store them into an S3 compatible store. So for this demo, we can say demo 1, 2, 3, right? And click on Create Backup, right? And within, I don't know, depending on the size of all the data that's sitting in the clusters, within a couple of minutes, the entire backup will be finished. And then once the backup is up and running, you can, of course, restore this backup, whether back to the same cluster, or if this cluster is completely gone, you can restore it onto a brand new cluster. So you have both options available.
Good stuff. Okay. How do I set policies for backup?
Yep. So that either you do it as part of the initial provisioning workflow, or you can go back into the settings and click on cluster settings. And here I can go down to the scheduled backups and again specify the policy. Is it going to happen on a daily basis, nightly basis? We even support a custom schedule. It's kind of like a cron-based scheduling where you can say, I want to schedule on every day at this time, blah, blah, blah. And you can see even examples of how often the backups would happen.
Great stuff. Okay. So the one topic that's always relevant is security, and especially with Kubernetes, when it introduces a whole new host of layers and technologies, how do we keep the InfoSec guys happy with Palette?
Yeah, great question. And what we're finding now is, especially with the DevOps methodologies and how teams are moving forward, is we're seeing this radical shift towards the left, not only when it comes to application development, but even the security aspects. What Palette provides with this declarative approach is letting even the info security guys have some say into what the security aspects of clusters look like. And the way we do that is under scanning, they can set up their own configuration policies for what are the security scans that run in the cluster, right? We integrate with a number of different tools for security. In this case, we're running something QBench that does a CIS benchmarking of the entire cluster. And using our UI, we get full visibility into all the various scans and all the reports and results that happen, right? In this case, looks like I had misconfigured some configurations, And that's why we see some warnings. And again, this is information that is easily reviewable by the info security teams. But more importantly, the entire policy of how often these scans run and configured is something you can also schedule to run on a daily basis or weekly basis. Also do note that we provide a mechanism for customers to download the security reports, whether it's a PDF or a CSV file format. In fact, one of our customers, what they do is before any major upgrade for Kubernetes, they'll go through their clusters, they'll download the report, making sure everything is clean, they'll perform the upgrade, and then download the artifact afterwards. They'll run the same scan, download the artifact, and compare, making sure everything looks good.
And that goes beyond just security scans, or actually goes into pen testing, cert rotation, conformance testing, all these nice little things, right?
Absolutely. And pen testing itself, we actively try to look at some vulnerabilities or using anonymous authentication or your certificate's expired. We try doing all these different types of scans against your cluster. And again, report back on what are the results and provide the same mechanism of downloading these reports. And the final one here is the conformance scan, right? You want to be sure that you're not being locked into a specific Kubernetes technology. What we provide is a mechanism that regardless of what technologies you pick, is do a conformance scan where we run a Sonaboy utility to ensure that all the different specifications of Kubernetes are met. Okay,
I want to pivot to something else and talk about locations here before we kind of close on the governance and visibility, which is always very relevant, especially for larger organizations. But we've talked about EKS, which is a managed Kubernetes service provided by Amazon. I think you mentioned OpenStack at VMware. Where else can we deploy?
Yeah, great question. So if I go back into the cluster profile section, right, you can take a look at all the various cluster technologies, right? Everything from managed Kubernetes, public cloud, you can pick all the VM-based technologies like EC2 and Azure VMs and so forth. But we also now support bare metal as a service. This is actually where we are provisioning on bare metal environments the full clusters. What we find typically is customers who want to deploy Kubernetes on a bare metal environment is that there is a very disjointed experience where there's a separate team that is managing the machines and the operating system. And then on top of it, another team that is managing the Kubernetes lifecycle. And we find that that becomes tedious, one, because as upgrades happen, they have to be done together. And number two, more importantly, is it takes away from some capabilities. Specifically when it comes to resiliency, where one of the nodes becomes damaged or unhealthy, in order to replace it, you really have to wake somebody up at 3 o'clock in the morning, have them install a brand new appliance, install the operating system, and then manage the Kubernetes lifecycle on top. Where we do things differently is we manage the entire stack. Everything from provisioning the actual machine to the operating system to the Kubernetes layer as a whole go. And the way we do this is through a technology called Canonical MAS. That's a bare metal management interface to manage the lifecycle of the bare metal machines.
So the holy grail of Kubernetes, which is bare metal deployment, because, and we've talked about this before, in my opinion, Kubernetes just doesn't need a hypervisor. You know, it was designed to be deployed directly and accommodate the application requirements. And we've solved the problem of disconnected experience and being able for Palette, the operating system, to be completely aware of it, right? So
absolutely,
you're just using one product to manage the complete stack, the full stack of that bare metal cluster. And effectively for Palette, it's just another cluster, right?
It's just another cluster. And it behaves, whether you're managing a public cloud cluster like EKS or managing a bare metal cluster in your private data center or colo, it's identical configuration. Again, we go to the extra mile of managing the machine, the operating system itself, so it's a single unified experience. But the day two capabilities, everything I showed you from providing backups to those different scan capabilities, those work the exact same way, the same experience, right? Whether it's a UI or whether you're doing, you know, through APIs or Terraform, works the exact same way.
Great stuff. Okay. Before we wrap this up, let's zoom out a bit and talk about governance and visibility. Because if this was intentionally designed, purposely built for large-scale Kubernetes deployments and large-scale organizations, how am I managing who's accessing, who's viewing? What is the super admin's role here?
Yeah, great question. There's two different levels of when it comes to RBAC and namespace and management and getting entire visibility across all your projects. I'll start with a simpler one first, that if you're within a project, you still have to manage all the various cluster, who has access to different namespaces and their different permissions. The way we do that is through a concept called a workspace. Workspaces allow us to manage and define a namespace that is actually a logical namespace that is distributed across multiple different clusters. So in this case, I've defined a team1 namespace that is actually deployed and managed across two clusters, my VMware Prod 1 as well as my VMware Prod 2. If I take a look at the configuration for it, right, again, I can specify which clusters belong to this workspace and the namespaces that are managed. I can also specify my role bindings. In this case, I'm saying that there is a admin level role that is mapped to this team1 namespace. And guess what? From my single sign-on, from my OpenID Connect, any user, when they authenticate that has a team1 admin subject, gets automatically added and has permission to be an admin in this namespace. It's a single place where you configure all these policies and be able to then enforce them throughout the process. For an operator user who's looking in this workspace or in this project, they get full visibility into seeing what are all the resources that are deployed in the namespaces, even across multiple clusters, and get the full cost aspect of that.
Do you think that Palette, that there's a use case for Palette to be used directly for developers? I mean, the UI is super intuitive, and I know there's implementations that we're giving a very new definition to what Kubernetes as a service means. But is this intended to be used by developers directly?
Absolutely. I mean, we don't want, because developers have different responsibilities. Some developers may only get access to kubeconfig. What we're also finding in some of the Kubernetes as a service use cases is where development teams themselves have access to a platform like Palette to provision their own clusters. Now, perhaps the IT operations team has limited the actual cluster profiles that they are available to choose because they want to lock down the technology choices, but the management can still be development. The other aspect of it is this workspace. You may not even give access to clusters and cluster profiles and audit logs. You give developers only access to their workspaces, to the namespaces they have access to, so that they can do their own resource utilization views of what pods are running, what deployments are running. We have a very granular set of RBACs that I can talk about a little bit, where you can see how users can have access to different parts of the platform. And that might be a realistic use case, absolutely.
Amazing. Okay, I know that the engineering team is moving super fast. So I have to ask you, what's coming in Q1? I think I have an idea, because when you were hovering over the cluster profiles, I saw Edge, and I really, really want to ask what's happening there.
Yeah, absolutely. So the MAS use case, the bare metal as a service use case you see here, this one here is for generally a data center use case, where you have a data center that has a bare metal management interface like MAS that is managing the lifecycle of 10, 15 or more machines. Edge is a little bit different. Think about your McDonald's use case where you have a store. In each store, if you want to run a Kubernetes cluster that is perhaps looking at, is telemetry information coming in from the cameras, looking at which people are coming in, taking a look at fraud, these aspects, you wouldn't not necessarily have 10 or 20 different machines running per store. In fact, you might only have 3 machines. Now, what do you do if you still have to manage the lifecycle of the Kubernetes, of the applications, and the core operating system? For there, we're introducing a brand new solution called Edge Bare Metal, where you can still, using a declarative approach, now manage all 3 layers, from your Edge operating system to the Kubernetes and all the applications that sit on top of it, right? And holistically be able to manage it for 100 stores, 1,000 stores, or tens of thousands of stores, with ease.
Anything else coming from the engineering team in Q1? Where's the product headed?
Yeah, and that's a great question. And one of the areas that we briefly touched on before as well is the development versus IT operations. For the most part, the development teams themselves don't worry about lifecycle management. They get access to Kubernetes clusters. Maybe they get access to a workspace so they can visually see what are the resources that they're running in their namespaces. But what developers do care about more so are the actual, their applications that they're developing and the applications that they consume. Frequently, what we see developers use are application services like databases and message buses and files object storage. We are trying to make it easy to provide all these different types of application services as content that developers can very easily build into a cluster profile and consume as part of their application. Managing the backup restore for Mongo, be able to manage the number of replicas running in Postgres, your Redis clusters, all these different aspects we want to be able to manage on behalf of the developers so that they don't have to worry about these.
I'm sure that if I can use it and play with it, I'm sure that a developer can as well. So that makes a lot of sense.
And the other aspect for is the IT operations teams. One of the interesting features we're building for them is how they deal with the application lifecycle management. Today, what we find are that applications, because of how the world is becoming globally available and globally distributed, applications are deployed as individual instances on clusters in my Europe region, in my US region, in my Asia region. The complexity of managing these individual applications, managing the global traffic load balancer, comes to the responsibility of the IT operations teams. So one of the areas that we're really looking into deeply is how can we make it easy for customers to manage a single instance of an application across multiple locations. Let the platform itself, let Palette itself, figure out the placement, the number of replicas, and the resiliency all automatically based on your specifications. So that feature is something I'm really looking forward to. Acosta is coming in Q1, Q2 of next year, and I think it'll really help customers move even faster, in Kubernetes.
So Palette will, beyond just the awareness that it has of the different integrations, it will have context of the actual application, of the actual aggregate of those integrations, not just from a Kubernetes stack perspective, right? Okay, that's impressive. Cool. Okay, thank you so much, Saad. This has been fantastic. And for everyone that's been watching, we'll be interrogating Saad Malik very, very soon. Enjoy your holidays and stay tuned for the next iteration of our webinars. Thank you so much.
Thank you.